Tell me your name, and I understand you're grad students. So what's your area of study?
My name is Jahangir. I'm a grad student here. I'm a fifth year PhD student, and I'm like from engineering science and mechanics with my research focused in material science.
And you?
My name is Yongwen Sun. Come from engineering science and mechanics department. Currently a third year PhD working in Professor Yang Yang's group.
Now, I understand that this afternoon you'll be presenting a poster. Tell me a little bit about the research that you're going to be presenting on that poster.
So basically, our group do a lot of work with the in situ TEM characterization. So we work with a lot of like samples from like the metallic samples all the way to like semiconductors, 2D materials, and so we can go like all the way to like the nanometric scale and like characterize the material. But the cool thing about our research and our group is that we can do the in situ stuff. So that means that we can test the material in its like real conditions. For example, under mechanical testing, but at like nanometric scale. For example, if we are like talking about from a chemical point of view, like how the material is behaving under different like temperatures, but we can like actually see the dynamic phenomena happening inside the TEM. So that is basically where our group stand out, and like we are like working with a lot of like different other groups. So we are having a lot of like collaborations with different groups and also with other universities.
Okay, tell me a little bit about that.
Oh yes, I'm going to talk about my presenters this afternoon section about the in situ 4D stem stream mapping of the zirconium oxidation. Zirconium is a cladding materials in nuclear reactors went through oxidation and easy to forming the cracks and shorten the lifespan. And we want to see the dynamic evolution under the MEMS gas cell TEM holder and how the stream maps change before the oxidation, how the crack formation happens.
Okay. Now, for graduate students like yourselves, how important is it to attend an event like Materials Day? What are some of the benefits that you can get out of that?
I think the most important thing you need to know the facilities you work with, what your colleagues are working on, and what is the new projects going on, and what's the new advancement of the technique. Especially in going to the event like this, there are a lot of companies talking about their new machines, softwares, and techniques. A lot of them we are using daily. So this really helps us advance our research or daily research routines or what.
Okay, how about you?
I think this is super important because when you are working with your like on your own research or with your own group, you are mostly in your own shell and you are like very focused on your research. So this kind of like events give you an idea that okay, what other people are doing, what are like the other areas that you can explore, or what are like the areas that you can collaborate and like make a better use of what you're already doing. So I think it is pretty cool, and at the same time having like different industries over here, that is a very plus point that can give you a chance that you can like connect with those people and also learn more about their equipment, because I think those are like the best people to tell that what are like the capabilities that you can use. It is like good to like talk with them so that you can really talk about the problems that you're having in your research or like the limitations, and might be they can like guide you in the better direction.
Wonderful. That was great. Thank you so much.